Good morning to all of you. Yesterday we have seen the different rays for the image formation in the case of spherical mirrors. I think all of you can recollect the 4 points along the diagrams. I'm just repeating the different rays considered for the image formation in the case of concave and convex mirror. First ray parallel to principal axis after reflection from the concave mirror passes through the focus. In the case of convex mirror, ray parallel to principal axis after reflection from the convex mirror appears to come from the principal focus. This is the most common and important one. Second one, a ray of light passing through principal focus after reflection from concave mirror becomes parallel to the principal axis. That is the second one. And in the case of convex mirror, the ray of light tends to pass through F after reflection becomes parallel to the principal axis. And third ray of light, a ray of light passing through the center of curvature after reflection from the concave mirror retraces its path. It's an example of normal incidence. I is equal to 0 and R is equal to 0. In the case of convex mirror, ray of light tends to pass through C after reflection from the convex mirror retraces its path. So you have to recognize these statements along the diagram in your mind. You have to recall all the diagram in the mind. And fourth one, a ray of light reaches at the pole obliquely after reflection, comes back to the same medium, obeying the laws of reflection I is equal to R. It is same in the case of concave and as well as convex mirror. So for the image formation, out of these four rays, which are very convenient for us, we take only two rays. So two rays are required for the image formation. So we can place the object anywhere, and to get its image, we consider any two of the above four rays for the image formation. Okay, and we get real image as well as virtual image. I am going to explain what are the differences between them. Okay, so we'll go to the screen, and so first we are going to discuss the image formation in the case of concave mirror. They are very important one. You are supposed to draw all these diagrams in the copy. Okay, yes. So image formation in the case of concave mirror. Image formation in the case of concave mirror. Okay, yes. So there are two types of images. First one is real image, and second one is virtual image. So we use the term frequently. So when we get real image and when we get virtual image, so that you have to just recognize the point. Real image is formed when the rays after reflection actually meet at a point. Actually meet. So when the rays after reflection from the mirror, they are actually meeting at a point, we get real image. Real image can be taken on a screen. If you have a screen there, we can take on a screen. So these are the speciality of real image. Real image formation is when the rays after reflection, they actually meet at a point. And we can take this real image on a screen. We can perform this experiment in the lab. Virtual image. Virtual image means, so rays actually after reflection do not actually meet. Do not actually meet. then what will do? They appear to come from a point. Okay, they appear to come from a point. They appear to come from a point. So we cannot take virtual image on a screen. Okay, we cannot take virtual image on a screen. So we cannot take virtual image on a screen. But all the images can be photographed. You can photograph real image. You can photograph virtual image, no problem. For example, if you are in front of plane mirror, you can take a photograph. Okay, object and image also can be photographed. So all image can be photographed. Image formed in the case of plane mirror is a virtual image. So it can be photographed but cannot be taken on a screen. So these 2 points mainly you have to remember. So concave mirror can form real image as well as virtual image. Real image means that after reflection, the rays are actually meeting at a point. Rays actually meet after reflection and can be taken on a screen. Whereas virtual images, they do not actually meet at a point, they appear to come from a point and therefore cannot be taken on a screen. Okay, cannot be taken on a screen. But both images can be photographed. So, one more question, can you photograph virtual image? Yes, we can photograph virtual image. Okay. Can you photograph real image? Yes, we can photograph real image. Can we take real image on screen? Yes, we are doing that in the lab. We can perform the experiment. So there are experiments in lenses and mirrors where we take real image on a screen. Okay, virtual images cannot be taken on a screen. That you have to. This point is important one. Okay, so we are going for image formation in the case of concave mirror. So depending upon the location of the objects, we get different types of images. Okay, we can place the object at different locations. What are the different locations? Just I'm going to show it. Okay, you can see. So concave mirror can produce both real and virtual image. So remember that point too. What are the different locations? You can see the different locations. Suppose you have a concave mirror here. This is your concave mirror. Center of the mirror we call it as P, and this is center of curvature. Straight line passing through the center of curvature and the pole. You know it is a principal axis, and this is principal focus. We can place the object far, far beyond C. We can call the object as AB. We can name it as AB, an object. Okay, very far you can keep, and beyond C you can keep, and the object can be at different locations. Say it can be at C, it can be between F and C, it can be at F, it can be between F and P. And object last, I am writing a object at infinity, infinite distance. Okay, for example, we take it as sun. So this is object here I am marking as a dotted line. So this is AB, the object is here at infinite distance. So these are the different locations where we are going to discuss. So you can see how many cases are there. First one, object very, very far. We say that object at infinity. This is the case number one. The next one is object is at finite distance. It is not very, very far, finite distance, but beyond C. That is a case 2, beyond C. And next one, object is now coming closer and it's now at C. Now the object is between F and C, and object is now at F, and object is now again coming closer. Now it is between pole and focus. There are 6 cases. So in all the 6 cases, we are to explain the image formation in the case of concave mirror. So what are the different locations of the object? What are the different locations of the object? You can draw this diagram, different location. First one, very, very far, we call it as object at infinity. Example, sun. A very, very far object. Next, little more coming closer, we say that it is a finite distance. Finite distance. Okay, finite distance. Say that is beyond, second case, beyond C. All these are finite distances. 2, 3, 4, 5, 6 are finite distances. So, beyond C, then at C, then between, what you'll say, F and C, then at F, then between P and F. So, location number 1, repeat, I am repeating the location, yaad karna hai. So, first object is at infinity, then beyond C, at C, between F and C, then at F, between P and F. So, first case, when the object is at infinity, where will be the image and what is the nature of image formed? What is the nature of image formed? So, that is the next part. So, case 1 we discuss concave mirror image formation when the object is at infinity. That is the first point. Case 1, object at infinity. For example, the sun. Objective, we are getting sun rays, we can focus sun rays on a sheet of paper by using concave mirror. So, that is the experiment here. So, this is already we have seen in the definition of principal focus, same diagram. So, this is your concave mirror, draw principal axis, okay, P, C principal axis. Rays object at infinity. So, the rays are parallel to themselves and parallel to principal axis. We can say the rays parallel to principal axis. Rays parallel to principal axis. Object is at infinity. Rays are parallel to principal axis, parallel to themselves. So, we can put some one or two dots here. So, that is object at infinity. After reflection, they are converging to a point. All are coming together. Okay, all are coming together, all the rays after reflection, they are coming to this point. And put the arrow marks are required in this. So, in all the ray diagram, this is a ray diagram, arrow marks you have to put, and this point is called the focus. So, the image is formed at F. So, your object is AB, it is at infinite distance, okay, and image is now formed at focus. The rays are actually meeting at the point, but it is a point size, very so image nature is here. Image is where the image is formed. Image is formed at focus. It's a real image because rays are actually meeting. Okay, real inverted image. It's an inverted image and very diminished, very diminished image. So, the nature of the image, location. So, the image is formed at focus. It's a real inverted and very diminished image is formed. You can focus sunlight on a sheet of paper. You can see a very fine spot, bright spot can be seen. That is the image of the sun. Even for a distant object also you can take it on a screen. So, it will be an inverted image. Okay, very diminished image and real because all the rays are actually meeting at the point. So, this is the case 1. So, when the object is at infinity, so you have to remember that where will be the image? It is at F, real image, inverted, very diminished image. Case 2. Case 2, we take object little more closer, object beyond C, center of curvature. Object beyond C, center of curvature. So, this is your concave mirror. You can draw principal axis, mark the points here P, okay, and here it is your C is here and F is here. Object is placed beyond C. So, this is your object, AB is your object. AB is the object placed beyond C. So, we have to consider any two rays for the image formation. So, I am taking the first ray parallel to principal axis from the head of object A, A से आ रहा है. After reflection, it passes through the focus. Okay, you can see here object AB is placed beyond C. First ray parallel to principal axis. After reflection, passes through the focus. The second ray of light, okay, that you can take, which is passing through the focus, after reflection, it becomes parallel and both will come and meet. So, second ray I am going to draw. The second ray of light passing through the focus. Two arrow marks I am marking here. After reflection from the mirror, it comes and meet here. Yes. So, here the image is formed. So, the two rays are actually meeting at this point. This is the meeting point. So, it will be like this. The head A will be here, so it is A dash and B dash. So this is the nature of image formation. You can see first ray parallel to principal axis, after reflection passes through the focus. Another ray passing through the focus, after reflection becomes parallel. Both rays are actually meeting at the point here. So it is A dash. A here on the top, now here it is down, A dash. You can see that it is an inverted image. Okay, image inverted. So image is doing शीर्षासन there. So उल्टा हो गया. So A dash B. It's a real inverse. So it's actually meeting. The rays are actually meeting. It's a real image. Inverted, but it is not very diminished, but diminished. The size is smaller than that of the object. So object size, if it is a 5 centimeter, you can take that. This will be less than that. It can be 3 centimeter. So less than 5 centimeter. Diminished. Okay, yeah, so we'll write here the location of the image. Image is, you can see that between F and C. It is between F and C. So image is formed between F and C के बीच में है. It's a real image. It is inverted image and diminished. That means size of the image is smaller than the size of the object. That is the meaning of diminished. Small image is smaller in size. Okay, so these two cases you can see, when the object is at infinity, we are getting very diminished image, points. This is a very point sized image is obtained. If we are coming closer to the mirror, beyond object is beyond C, so we are getting diminished image. It is not very diminished, it is diminished image. Okay, again we are coming closer. Suppose the object is now and we are going to place at C, then what will happen? That is the case 3. Okay, also to make all these diagrams in the copy. Yeah. So we are going for next case, object at C. Object at C. That means object is initially it was at infinity, dire dire coming closer to the mirror. Now object we are going to place at C, that is case 3. So case 3, object is now at C of concave mirror. So this is your concave mirror, this is your principal axis. P, F and C you can mark. P, F and C. Your object is at C. This is your object. AB is at C. We consider the rays. First ray parallel to principal axis. After reflection passes through the focus. See the arrow mark. So first ray is this. In all the image formation we use this. In all the image formation this ray is considered. That is ray parallel to principal axis from the object after reflection passes to the focus. In all the cases we consider this ray. So second one you can take any choice you can take. There is no objection that. So here I am taking second ray that is passing through the focus. Second ray is passing through the focus. After reflection, it becomes parallel. Parallel to, it becomes parallel. So after reaching here, parallel, it comes here. And meeting at this point. Okay. Second ray after reflection becomes parallel and meeting at this point. So at this point, we get the inverted image of the object. Okay, this is the point C. So we are getting the inverted image at this point. The second ray passing through the focus along this way after reflection meets at this point. So here you are getting A dash. A dash B dash will be your image. A dash and B dash. So this is your image. And you can measure the height. If AB is 5 centimeter, you can measure and see this A dash, but this is also 5 centimeter. So you can see the size of the image is same as that of the object. Only in this case, when the object is at C, where is the image formed? Image is at C itself. Image is at C, center of curvature itself. What is the nature? Okay, it's a real image, inverted image, and size. And it is of same size. That is a very important one. Same size. So this is the only case where the concave mirror produces an image size which is equal to that of the object. The object is 5 centimeter. Image is also 5 centimeter. A real image, because the rays are actually meeting at this point dash, inverted, okay, inverted image, and image size, it is of same size. So this is the case 3 when the object is at C. So I repeat, when the object is at C, first ray parallel to principal axis, after reflection passes the focus. Second ray is passing through the F and after reflection becomes parallel and both rays are meeting at this point where we get the image. So A dash B dash is the real inverted image formed at C and it is of same size. So same size of image. If you remember, in the case of plane mirror, we get the size of the image is same as that of the object, but it's a virtual image. And for all positions, we get same size. That means size of the image will be equal to size of the object in plane mirror. You stand anywhere. But in the case of concave mirror, this is the real image, and its size is equal to the size of the object only when the object is at C. So it is a special case. Take care of this one. Next, we go for little more closer. The object is again coming closer, and now if it is between F and C, okay, between F and C, then we'll see what will be the nature of the image and where it will be. So we are going for case 4. Case 4, object is now between F and C. F and C. Diagram. Principal axis P, F, and C. Now the object is here between F and C. Principal focus and center. First ray of light from the object, as usual, we take parallel to the principal axis. Parallel to principal axis. After reflection, passes through the focus. So there is no change, exactly the same way. So this is the ray after reflection passes through the focus. Next one, another ray you can take that is passing through the focus. Second ray I'm drawing here, passing through the focus. reaches here. After reflection, becomes parallel. So you can see that the diagram is here. This is parallel to the principal. So it is coming in this way. So both are here meeting at this point. So here I am marking the point C. So this point will be marking as C here for convenience. Yeah. So AB is your object and the point C I am marking here a little more closer. Okay. So the two rays are meeting at this point here and it is beyond, we are getting it is beyond C. And so this is the image we are making here. Yes. This is A dash and B dash. So I repeat the two different rays. First ray parallel to principal axis we have taken in all the cases. After reflection passes through the focus. Yes. Second ray is passing through the focus becomes parallel to the principal axis. Both are actually meeting at this point A dash. So A dash B dash is the real inverted image. And what you can see the size? Size slightly bigger. It is bigger. Suppose AB size is 5 centimeter. You can see A dash B dash is bigger than that. It can be even 6 centimeter or even 7 centimeter. So this is we call it as enlarged image is formed now. So image nature is now image location we'll write it as image is beyond C. Okay, beyond C. You can see image is beyond C. Real image, inverted image, and now it is enlarged image. Enlarged image means size of the image, enlarged or magnified image we बोल सकते हैं, enlarged or we can say that magnified image. Enlarged or magnified image. That means size of the image is greater than that of the object. Or if object is 5 centimeter, so marked as 5 centimeter, then image size will be greater than that 5 centimeter, 6 centimeter, 7 centimeter, 8 centimeter, depending upon the position. So enlarged image is obtained. It's a real image, inverted, enlarged, magnified. Enlarged means magnified image, size of the image is greater than that of the object. So we have seen 4 image formations and 2 are left. Also complete this diagram in the copy. And you have to remember the location of the image in all cases and the nature of image. Okay. Next we see case number 5. So again object is coming closer and if it is at the focus, where will be the image? So that will be the next case. Case 5, when the object is at focus, at F. So your concave mirror, principal axis, this is P, this is F and this is C. Where is the object now? Object is at F. AB is your object. It is placed here. This is your AB object. Object is at F. First ray of light, again we take parallel to principal axis as usual. The ray parallel to principal axis. After reflection, what will happen after reflection? A parallel to principal axis. After reflection passes through the focus. Yes. So after reflection, it passes through the focus. It is this way. The first ray of light after reflection passes the focus. The second one, for convenience, I am taking the second ray. ray that is reaching to the pole. Second ray. If you remember, this is the fourth case of the rays. A ray of light reaching at the pole, obeying the laws of reflection, and I is equal to R and reflects in this way. Yes. Two rays are here. Okay. So here you can see that first ray parallel to principal axis after reflection passes the focus. For convenience, we can use any ray out of four. So this is the last option method. And ray light reaches obliquely at the pole at an angle of incidence I. This is angle of incidence, angle of reflection, obeying the laws of reflection, reflect into the same medium. Second ray is coming here. And if you see on left side, so these rays are not meeting anywhere. Suppose you are standing here. These rays are not exactly meeting at any finite distance. So they are supposed to meet at infinite distance. Okay. So here this is angle of incidence, angle of reflection, I is equal to R oblique incidence. So these rays are not, so they are supposed to meet where at infinite distance. As it goes like this, you can see that the rays I am extending here, when we extend the rays, it will go like this. So this is the way we extend. As we go and extending, just see the image size. So this is your principal axis. The size of the image will be they are supposed to meet at infinity. So as they are meeting at infinity, the size of the image is going bigger and bigger. So what we get it as the image will be formed at infinity because parallel ray is supposed to meet at infinity. When they are meeting at infinity, the size of the image will be highly magnified. So it will be a real image, it's an inverted image, and it is highly magnified. So highly magnified image is formed because you draw the line. So when you draw here 6 centimeter, here 7 centimeter, 8 centimeter, 9 centimeter, as it goes to infinite distance, the size will go on increasing, the image size will go on increasing. So we say that it is highly magnified image. Highly magnified image. So you have to remember when we'll get highly magnified real inverted image in the case of concave mirror when the object is at focus. Very important. Okay. Image when the object is at focus, image is formed at infinity. It's a real image and inverted, highly magnified image. Highly magnified image. So this is the case 5. Highly magnified image. Now, next one is case 6, that is when the object is again coming closer to the mirror, it's very close in front of the mirror, very close between F and P. Then what will happen? That will be the next point. Case 6. So, case 6, object in between F and P, and this is a very, very important one. Very, very important. Because only in this is the case where it can form virtual image. Only in this case, concave mirror can form virtual image. Okay, listen to the diagram. Concave mirror, principal axis, P, F, and C. Any convenient rays can be considered. Object is now between F and P. AB is your object. First ray parallel to principal axis, after reflection passes through the focus. Yes. First ray of light parallel to principal axis after reflection passes through the focus. Yes. Next one, again I am going to take the fourth case, second ray of light going reaching to the point that is a pole. This is the second ray of light. After reflection, this is the angle of incidence. It obeys the laws of reflection and reflects back. I is equal to R. Just see here, if you are somebody standing here on left side, you can see that these two rays are diverging and going, diverging and moving, diverging. Diverging means they are not going to meet anywhere. This is the way how it goes. Okay, so they will not meet anywhere here. They are going like this. See, so that distance is increasing. We call that diverging and going. So if you see, if you are standing here, the rays appears to come from a point. So extend these rays backward. So these rays are extended. First ray is extended back. Second ray is also extended back. So these rays are extended back, and for an observer here, say hello, they are making the hello. For the observer, these two rays appears to come from a point here. So where you get the virtual image, A dash B dash. So if it is AB is here, it will be A dash. You get the image like this. So the rays appear to come from A dash. So this is a virtual image, and image location is behind the mirror. Now it will not be in front. So image is behind the mirror. Okay, image is behind the mirror. And what other point you'll see? It is a virtual image. Rays are not actually meeting, but appear to come from A dash. Virtual image. It is erect. Exactly the same shape may image. So it is an erect image, but the size you can see that it is an enlarged image. Is enlarged, or we can say that it's a magnified image. So this is the only case where we get virtual image. When the object is in between pole and focus. Okay, we get virtual image. This is only the case where the concave mirror can form what? Virtual image. It's erect image. All virtual images are erect. Same shape milte, just like a plane mirror we are getting. And it's enlarged and magnified image. So I think this clear to all of you. So the 6 cases, all the diagrams should be there in the copy. So this is the only case where the concave mirror can form virtual image. Okay. So all the 6 cases, locations, you have to recognize all the 6 cases, the location of the object and the position of the image and their nature. So next class again will revise the different locations and the nature of the image. Okay. So thank you. So draw all the diagrams in the copy, all of you.